Welcome, Bill Rosman from MC Assembly, to a brief video demonstration of the Fancourt benchtop router. Bill, I know you wanted to see a two-part video, the first part being a very short tutorial or explanation on how to program the benchtop router, and then secondly, of course, an actual demonstration with the panel that you had sent to us last week. So what we're going to do on the first part of this video, I'm going to have our technician, Phil Van Pelt, just give a very quick and simple overview of the programming of a panel on the benchtop router. Please bear with us, as it may get a little blurry from time to time as we try to focus in on the handheld pendant that's used for programming, but we'll get it clear for you, don't worry. Okay, Phil, go ahead, sir.
Okay. I'll just let Steve try to focus in on the pendant a little bit, and I'll try.
Okay, Bill, now that you've seen the first part of the video, which gave you an overview of the programming of the router, I just wanted to do an overview of the actual physical routing setup here prior to us processing your panel. First of all, I just want to talk about the setup a little bit here. Obviously, this is the robot platform that you're looking at here. And this is our up vacuum version in the 2300 size, which is an approximate 12-inch in the XY directions range of motion. The panel that you provided us is about 120,000 thick, which compared to a lot of jobs we've done is a relatively thick panel. With the up vacuum chuck and router bit here, what we had to do is we had to slide out this routing bit a little bit more than usual as far as how far it's up into the chuck here, so that we made sure that we got through the total thickness of this board. We've used an 0.62 diameter routing bit, which is very close to the size of the slot that we're going in there. So that can be adjusted later on. We can maybe use a smaller one if we need to, that kind of thing. Just to let you know also, as far as the speed of this, we're only going about 5 millimeters per second, which is conservative and relatively slow for the router. But again, it's because of the thick panel and also the fact that we didn't test anything prior. This is going to be our first run through a full panel. To go through the physical setup here, again, this is the robot which I described earlier. You're looking at the spindle motor and chuck here, which in the up vacuum version holds the vacuum and the routing bit. Over here is the control box, which has the routing bit, spindle motor controller in it. You can see the hose here coming out, that clear hose. That's what's taking the debris away as the tabs are eliminated. Over here, a feature we have on the up vacuum system is we have what they refer to as a spindle motor load indicator. Really all it is telling us if we have a problem, is if when the routing bit is cutting through that tab, is if it's under too much stress as far as the ability to cut that tab, or the speed that it's going is too quick. It'll give us an indication that we're putting too much load or pressure on that routing bit while we're doing it. Again, over here is just the control box with the facilities in it, including the spindle motor. Down here is the pendant, which Phil had showed you earlier as far as the programming of the points and the speed. And here is what we refer to as a remote type of start, emergency stop button. So we're ready to go. One thing Phil didn't mention on the programming is each program is numbered, and in this case it's program number 6 that's indicated at the top of the pendant for this particular panel. So we'll get this started for you and show you it being processed.
Time sheet is going to cut.
Okay, Bill. That was the panel being processed. It's about a little over 39 seconds. But again, we really slowed down the speed because we didn't have much trial and error here to make sure that the routing bit would be able to handle it, and also that we would make sure that we weren't going off line by going too fast here. As far as the load indicator we looked okay on it. It got a little high, but not in the danger zone at all, so we probably can speed it up ever so slightly. Now, the one thing I just wanted to mention prior to us finishing the video is I didn't talk about the fixture, obviously, for the up vacuum. It's an adjustable fixture. It consists of a plate with many tapped holes in it so that you can use these movable and adjustable supports that are placed strategically all along the panel depending on your panel design. What Phil did here was on the edges, in order so that nothing fell while it was being singulated, he used just the support part of the pin to support. While in other spots, you actually would use the stud or pin part of the support to go into a tooling hole to keep it from moving and also provide other support. Now, the good thing about the adjustable fixture, as you know, is you had another panel that you wanted to put on here. You could use the same supports and move them around depending where you needed to go. The only thing you may have to change is if you do use the pins for tooling hole support, the diameter of those pins would have to change. You can make them yourself, you can buy them commercially, Fancourt could even make those for you. But the adjustable fixture gives you a good base to probably build 80% of any fixture that you would ever need, if not more than that, at any one time. Okay, let me just, I'll take off the board here. You can see the pieces will come off. And there's your singulated panel. And our technician here, Phil, who spoke earlier, did a heck of a job. I mean, that is really nice on the edge. Great job. All right, so we'll send you this video, Bill. We'll send you the sample back, and we'll go from there. Thank you very much for all your time.